In question 1, we need to find this indefinite integral, giving our answer in its simplest form. So we start by writing the integral in index form. So it's 10x to the power of 5 plus 6x cubed minus 3x to the minus 2 dx. So we increase the power by 1, 10x to the 6 over 6 plus 6x to the 4 over 4, we divide by the new power, minus 3x to the minus 1 over minus 1 plus c. Now this simplifies to 5x to the 6 over 3 plus 3x to the 4 over 2, and it's going to be plus 3 over x plus c. In question 2, we are told that triangle ABC satisfies these conditions here, and we need to use the sine rule to find the value of sine x to 4 decimal places. It certainly makes sense to draw a triangle just to put all the information there. So we've got triangle ABC. We know that AB is 21 centimeters, BC is 13 centimeters, angle BAC is 25 degrees, and the angle ACB is x. So we can easily say that sine of 25 over 13 is equal to sine of x over 21. This means that 21 sine of 25 over 13 is equal to sine x, which gives an answer for sine x of 0.6827. Given also that AB is the longest side of the triangle, we need to find x to 2 decimal places. Now we know that if AB is the longest side, that means that x, the angle opposite the longest side, must be the largest angle. So we could proceed as usual to find x. We do shift sine of 21 sine of 25 over 13 for x, which turns out to give us a value of 43.05. If x was 43.05, then the angle ABC here would have been found by saying that ABC is 180 minus the 25 and the 43.05, which gives an answer of 111.95, which certainly violates the fact that x had to be the largest angle. So what do? We address this by considering that sine of theta and sine of 180 minus theta are exactly the same. So supplementary angles have the same sine ratio, and therefore we could say that x must be 180 minus 43.05, which gives an answer of 136.95 degrees. In question 3, we need to show all stages of the working without the use of calculator technology, and we start by being asked to show that this expression is an integer and we have to find its value. One approach we could employ is considering that since we've got one term in the denominator, we can express each of the numerators over that denominator. So it's going to be root of 180 over root 5 minus root 80 over root 5. So root of 180 over root of 5 is simply root of 36, because 180 over 5 is 36 and 80 over 5 is 16, so that's root 16, which gives me 6 minus 4, which turns out to be 2. In II, we need to simplify this fraction here, giving our answer in the form a plus b root 5, where a and b are rationals. We've got 4 root 5 minus 5 over 7 minus 3 root 5. We will multiply by 7 plus 3 root 5 over 7 plus 3 root 5. Reminder here that what we are doing is that we are setting up a difference of two square fractions in the denominator so that we can get rid of the roots in the denominator. So 4 root 5 times 7 is 28 root 5, and then it's 12 times root 5 times root 5, which is 5, minus 35 minus 15 root 5 over 7 times 7 is 49, plus 21 root 5 minus 21 root 5, minus 3 times 3 is 9, and root 5 times root 5 is 5. So we've got the 21 root 5 with the minus 21 root 5 cancelling out as expected, and we are left with 28 root 5 plus 60 minus 35 minus 15 root 5 over 49 minus 45, which further simplifies into 25 plus 13 root 5 over 4. We haven't finished, we need to put in the form of a plus b root 5. So this is 25 over 4 plus 13 over 4 root 5. In question 4, we're given the graph of f of x. It has a minimum at p, a maximum at q, and a horizontal asymptote at y is 1. And we are asked to sketch the curves with equations f of x minus 2 and f of minus x. Let's start by considering exactly what transformations we're dealing with. The f of x minus 2 simply means that we deduct 2 from y. So it's a translation 2 units down. The f of minus x simply means that we multiply x by minus 1, and this means that anything that was on the right now appears on the left, and anything that was on the left now appears on the right. So it's effectively a reflection along the y-axis. So starting from the first part, we need to consider each point where it's mapped to. So the minus 1, 0 will be mapped to minus 1 minus 2 because I'm deducting 2 from y. The 3 over 2 comma 2 will get mapped to 3 over 2 comma 0, and the asymptote, which was originally at y is 1, will now go to y is negative 1, and therefore the graph should look something like this. In I, we said that we will be multiplying the x's by negative 1. So the point minus 1, 0 will now appear at 1, 0. The point 3 over 2, comma 2 will now get mapped to minus 3 over 2, comma 2, whereas the asymptote y was 1 will still remain exactly at the same position. The y values are not affected, and so the graph will look something like this. In question 5, we are being told that f of x is a quadratic expression having a maximum at minus 212 and cutting the negative x-axis at negative 5 as shown here, and we need to find an expression for f of x. I will start by writing that f of x must be of the form of 12 minus alpha x plus 2 squared, which essentially means that I'm enforcing a structure that will make the maximum at x is negative 2, which will make y 12. And the thing now is to find alpha. I will be using the fact that f of negative 5 is 0, which means that 0 is 12 minus alpha times 5 plus 2 all squared. So 0 is 12 minus alpha times minus 3 squared. So 0 is 12 minus 9 alpha. 9 alpha is 12, which makes alpha 4 over 3. And therefore f of x is 12 minus 4 over 3 x plus 2 squared. In part B, we are told that the line L1 has equation y is 4 over 5x. And given that the line L2 is perpendicular to L1 and passes through the point minus 5, 0, we need to find the equation of L2 in the form y cos mx plus c. So I start by writing the equation for L1. So L1 has equation y is 4 over 5x. So the gradient of L1 is 4 over 5. And since L2 is perpendicular, then the gradient of L2 is minus 5 over 4. We are flipping and changing the sign. In addition, we know that L2 passes through the point minus 5, 0. So I'm using y minus y1 is mx minus x1, which means that y minus 0 is minus 5 over 4 brackets x minus 5. So y is minus 5 over 4 brackets x plus 5, which simplifies to y is negative 5 over 4x minus 25 over 4. In C, we need to define the region R, here the shaded region, using inequalities. We can see that we are below the parabola and we are above the two straight lines. So we can easily conclude that, first of all, y is less than or equal to 12 minus 4 over 3 brackets x plus 2 squared. We are below the parabola. And we are above the line L1, so y is greater than or equal to 4 over 5x, and y is greater than or equal to minus 5 over 4x minus 25 over 4. Question 6, part A, given the two equations here, we need to end up with this quadratic in x. So I start from y minus x cubed plus 6x is 0. So y is x cubed minus 6x, and I'll be substituting into 2xy minus 3x squared is 50. So this means that I've got 2x brackets x cubed minus 6x minus 3x squared is equal to 50. And we've got 2x to the power of 4 minus 12x squared minus 3x squared is 50. Collecting everything on the left-hand side leads to 2x to the power of 4 minus 15x squared minus 50 is 0 as required. We are then told to solve the simultaneous equations, giving our answers in fully simplified form. So we are dealing with a quadratic in x, and I notice that if I let w be x squared, this will make w squared x to the power of 4, and I will be able to translate this into a quadratic in w. It leads to 2w squared minus 15w minus 50 is equal to 0. So this factorizes into 2w plus 5 brackets w minus 10. So either 2w plus 5 is 0 or w minus 10 is 0. Now this means that w is minus 5 over 2, so x squared, w is minus 5 over 2, which is of course rejected. It's not valid. I cannot raise a real number to the power of 2 and get a negative result, so this is clearly rejected. For w is 10, we have that x squared is equal to 10, so x is plus minus root 10, and we can now proceed in finding y. We know that y is x cubed minus 6x. It makes sense to write this as y is x brackets x squared minus 6. It will make the calculation of the y values a bit easier. So when x is root 10, we get that y is root 10 and x squared is 10 minus 6. So this is 4 root 10. Whereas when x is minus root 10, we get y is minus root 10 brackets 10 minus 6, which is fine as 4 root 10. In question 7, we are told that f dash of x is this expression here. We need to find the value of a. In addition, we know that f dash dash of x is 0 when x is 4. So I'm starting by writing f dash of x in index form. So it's going to be 2x to the minus a half plus ax to the minus 2 plus 3. And therefore, f dash dash of x will be 2 times minus a half times x to the minus 3 over 2 plus a times minus 2x to the minus 3, which gives an answer of minus x to the minus 3 over 2 minus 2ax to the minus 3. It makes sense to write this as minus 1 over x to the 3 over 2 minus 2a over x cubed. And we can then proceed with the fact that f dash dash of 4 is 0, which leads to 0 is minus 1 over 4 to the 3 over 2 minus 2a over 4 cubed. And therefore 0 is minus 1 over 8 minus a over 32, which leads to a over 32 is equal to minus 1 over 8. And we can cross multiply to get that a is minus 4. In part B, we need to find f of x, giving each term in its simplest form, given additionally that f of x is 8 root 3 when x is 12. So we start from f dash of x. We have that f dash of x is 2x to the minus a half minus 4x to the minus 2 plus 3. We've replaced the value of a with the value we just found in part A. So to find f of x, we integrate. So it's the integral of 2x to the minus a half minus 4x to the minus 2 plus 3 dx, which gives 2x to the a half over a half minus 4x to the minus 1 over minus 1 plus 3x plus c, which leads to 4x to the a half plus 4 over x plus 3x plus c. Now, we know that f of 12 is 8 root 3, so f of 12 is 8 root 3, and therefore 8 root 3 is 4 times 12 to the a half plus 4 over 12 plus 3 times 12 plus c, which leads to 8 root 3 is 8 root 3 plus 109 over 3 plus c. Now the 8 root 3 with the 8 root 3 cancel out, and therefore minus 109 over 3 is the value of c, and therefore we can proceed into writing that f of x is 4x to the a half plus 4 over x plus 3x minus 109 over 3. In question 8, we've got a sketch of the outline of the face of a ceiling fan viewed from below. We know that the small circle has a radius of 9, so this here is 9 centimeters. The radius of the bigger circle, this part here, is 84 centimeters. And in addition, we have that angle AOD is 2 pi over 3, so it makes sense to add all this information on my diagram, 2 pi over 3. And given that the length of the arc AB is 15 centimeters, we need to show that the length of the arc CD is 35.9 centimeters to 1 dp. So we know that the arc AB here, this one here, is 15 centimeters. So I'm trying to find the length of the arc CD, which is this part here. So in order to do that, let me start by reminding ourselves that the length of the arc is r theta, and we have that the arc AB is 15, the radius is 9, the angle is AOB. So we get that 5 over 3 is the size of AOB. Remember, we are in radians. And therefore, the angle DOC will simply be 2 pi over 3 minus 5 over 3, which can be written as 2 pi minus 5 over 3. And therefore, the length of the arc DC will be the radius, which is 84, times the angle, which is 2 pi minus 5 over 3, which gives an answer of 35.929, which rounds to 35.9 centimeters to 1 dp as required. In part B, we need to find the perimeter of the face of the fan, giving our answer to the nearest centimeter. So if we look at the fan, it's this part here. So we need to find the perimeter of this. So if we think about it, we've got 6 straight line parts. We've got 3 arcs, the big arcs, and then 3 smaller arcs. So the perimeter will be 6 times the 84 minus 9 plus 3 times the length of CD, which was found to be 35.9, plus the 15, which is the arc AB. So the 15 is what I'm shading in green, The 84 minus 9 is what I'm shading in red, and what I'm shading in blue is the 35.9. So if I add this up, I will be getting the perimeter. So doing the calculation gives me a final answer of 603 centimeters, correct to the nearest centimeter. In part C, we're asked to find the surface area of the face of the fan, and in order to do that, I will be redrawing the diagram and I will be shading exactly what I need to find. Essentially, what we're trying to do is find the area of the big sector here, and then the area of the smaller sector here, and you've got 3 of each. We recall that the area of a sector is a half r squared theta. So we start by reminding ourselves that the angle of the smaller sector here is 5/3, and the angle of the bigger sector is 2 pi minus 5/3. We know that the radii are 84 for the big one and 9 for the smaller one, and therefore the area will be given by multiplying 3 times a half r squared theta plus a half r squared theta for the smaller sector. We put everything on the calculator, we get an answer of 4,730 squared centimeters. In question 9, we are given the graph of sine x, and we are told that sine of alpha is p for alpha between 0 and 90. We need to state in terms of p the values of these expressions. I will start by adding the cuts on the x-axis. We are at 180, 360, minus 180, minus 360. So sine of alpha is p, simply means that if I draw a horizontal line, the line y equals to p, then the first cut here in the positive is alpha, and by symmetry I can see that the second cut will be at 180 minus alpha. This means that sine of 180 minus alpha is also p, and therefore the first answer will be simply 2p. Now for sine of alpha minus 180, I see that the alpha minus 180 is a reflection of the 180 minus alpha along the y-axis. So if I was to draw the line y equals to negative p, which is somewhere here, then this point here will be alpha minus 180. Then this point here will be alpha minus 180. So its sign will simply be negative p. And finally, for the 3 plus sine of 180 plus alpha, the 180 plus alpha will be here. Alpha decrease after the 180. So we know that the sine of 180 plus alpha will be negative p, and therefore 3 plus sine of 180 plus alpha will be 3 minus p. In part B, we need to sketch the graph of y sine 2x on this diagram. Well, sine of 2x is a squeeze along the horizontal scale factor of 2, so I'm dividing all the x values by 2, and where originally I had one complete wave within 360 degrees, I now have 2 complete waves, so the graph will look something like this. And then in part C, we are told to find in terms of alpha the x-coordinates of any points where sine of 2x is equal to p. So if I draw the line once more of y equals to p, it's here, and we need to find the cuts. So we can see that the cuts are now at this point and this point. They were originally at alpha and 180 minus alpha, so we had 2x equals alpha and 2x equals 180 minus alpha, and therefore the solutions are at x is alpha over 2 or x is 180 minus alpha over 2. In question 10, we are given a sketch of curve C and we need to find the y dx. So we can start by writing out the equation for y, and we can differentiate. This will give me dy dx is 2 over 7 times 3x squared plus a 7th times 2x minus 5 over 2. The k is a constant, its derivative is 0, which simplifies to 6x squared over 7 plus 2x over 7 minus 5 over 2. In B, we are told that the line L here is normal to A and tangent to B, and we need to show that the x-coordinate of the point B is a solution of this equation. The only thing we know is that the point A has x-coordinate minus 7 over 2. So I will start by evaluating dy dx at x is minus 7 over 2. This will give me the gradient of the tangent at A. So dy dx at x is minus 7 over 2 is 6 over 7 times minus 7 over 2 squared plus 2 over 7 times minus 7 over 2 minus 5 over 2, and this gives an answer of 7. We conclude that the normal at A has a gradient of minus 1 over 7. I flip and I change the sign. Now, since this line L is a tangent at B, it means that at B we satisfy that dy dx is equal to minus 1 over 7, and therefore we've got that 6x squared over 7 plus 2x over 7 minus 5 over 2 is equal to minus 1 over 7. Now the LCM here is 14, so this leads to 12x squared plus 4x minus 35 is equal to negative 2, and therefore 12x squared plus 4x minus 33 is 0 as required. In C, we need to find the x-coordinate of B, justifying our answer. So we simply have to solve the quadratic equation we've just obtained. This can be factorized into 6x plus 11 times 2x minus 3. This is equal to 0. So either 6x plus 11 is 0 or 2x minus 3 is 0, which leads to x being minus 11 over 6 or x being 3 over 2. Now we reject the negative solution since we can see from the diagram that the x-coordinate of point B is positive. So we conclude that x is 3 over 2. In part D, we need to find the value of k given that the y-intercept of line L is negative 1. I will start by finding the y-coordinate of point B in terms of k. So we substitute x is 3 over 2. So when x is 3 over 2, we get that y is 2 over 7 times 3 over 2 cubed plus 1 over 7 times 3 over 2 squared minus 5 over 2 times 3 over 2 plus k. This gives an answer of minus 69 over 28 plus k. We know that the line L has a gradient of minus 1 over 7, and it's also passing through the y-axis at negative 1, so its equation is y is minus 1 over 7x minus 1. And in addition, we know that it passes through the point with x-coordinate 3 over 2 and y-coordinate minus 69 over 28 plus k. So I can substitute. I have minus 69 over 28 plus k is equal to minus 1 over 7 times 3 over 2 minus 1. So we get that minus 69 over 28 plus k is equal to minus 17 over 14, and therefore k will be minus 17 over 14 plus 69 over 28, which turns out to be 5 over 4.